There has two types of DC generator. First, separately excited DC generator. Second, self-excited DC generator. Self-excited DC generator is a device in which the current to the field winding is supplied by the generator itself. In self-excited DC generator, the field coils may be connected in parallel with the armature in the series, or it may be connected partly in series and partly in parallel with the armature windings, or these are generators in which the field winding is excited by the output of the generator itself.
Modern DC generators with field coils are self-excited generators which get started with the initial current in the field coils. When generator is switched off, a small magnetism is developed in rotor iron, which include electromotive force in the same armature, due to which current is produced in the field windings. Initially, weak magnetic fields creates less current in the coil, but to sustain self-excitation, the additional magnetic flux increases the electromotive force in the rotor, due to which voltage keep on increasing until the machine takes the full load.
What are self-excited DC generators? The small amount of magnetism is present in the rotor iron. This residual magnetic field of the main poles induce an electromotive force in the stator coils, which produces initial current in the field windings. Due to flow of small current in the coil, an increase in magnetic field occurs. As a result, voltage output increases. In turn, increases the field current. This process continues as long as the electromotive force in the armature is more than the voltage drop in the field winding. But after a certain level, field poles get saturated, and at that point, electric equilibrium is reached and no further increase in armature EMF and increase in current. The resistance of the field winding a certain fixed value at which self-excitation can be achieved. This resistance value may vary according to electric parameters of the generator.
There are three types of self-excited DC generators. They are DC series generator, DC shunt generator, and DC compound generator. But we only discuss the DC series generator. A series DC generator in which the armature winding is connected in series with the field winding so that the field current flows through the load as well as the field winding. The field winding is a low resistance, thick wire of few turns. Series generators are also rarely used. Applications of series field DC generators. We do not normally use series field generator for purpose of power supply. This is because of its racing external characteristics, but sometimes we can safely use series field DC generator for long DC transmission system and for railway distribution system because of its typical racing external characteristics. This racing external characteristics helps to prevent the line voltage drop for long transmission and distribution network. The terminal voltage of series generator increases with the load current from no load to full load. The series DC motors are used where high starting torque is required and variation in speed are possible. For example, the series motors are used in the traction systems, cranes, air compressors, vacuum cleaners, sewing machine, and etc.
Booster. A booster was a remote generator set used for voltage regulation in direct current electrical power circuits. The development of alternating current and solid-state devices has rendered it obsolete. Boosters used to compensate the voltage drop in the feeder in various types of distribution systems such as railway service. In the days of the recurrent mains, voltage drop along the line was a problem, so line booster we used to correct it. Suppose that the mains voltage was 110 volts. Houses near the power station would receive 110 volts, but those remote from the power station might receive only 100 volts. So a line booster would be inserted at an appropriate point to boost the voltage. It consisted of a motor connected in parallel with the mains, driving a generator in series with the mains. The motor ran at the depleted mains voltage of 100 volts, and the generator added 10 volts to restore the voltage to 110 volts. This was an inefficient system and was made obsolete by the development of alternating current mains, which allowed for high voltage distribution and voltage regulation by transformers.
Vacuum cleaner, also known simply as vacuum or a hoover, is a device that causes suction in order to remove debris from floors, upholstery, draperies, and other surfaces. It is generally electrically driven. The suction motor is one of the most important part of the vacuum cleaner. It is this motor which takes the electrical power from the power source and converts it into mechanical power in the form of suction with airflow. Rating the motor for its ability to produce suction with airflow is one of the most misrepresented and misunderstood aspect of vacuum cleaner technology. This confusion has become accentuated by many manufacturers in their attempt to make the product appear superior to others. Various methods of rating the suction motor's performance are discussed in the article on the power of the suction motor. Suction motor that is a part of the vacuum cleaner also it increases the load current from no load to full load.
Elevators, also called lift, car that moves in vertical shaft to carry passengers or freight between the levels of a multi-story building. Most modern elevators are propelled by electric motors with the aid of counterweight through a system of cables and sheaves pulleys by opening the way to higher buildings. The elevator played a decisive role in creating the characteristics urban geography of many modern cities, especially in the United States, and promises to fill an indispensable role in the future city development. It shows that its terminal voltage of series generator increases with the load current from no load to full load by pressing the buttons and the motors reacts. The current changes from no load to full load.
DC generators are divided into two types: separately excited DC generator and self-excited DC generator. Again, the self-excited generator is divided into three types. They are DC shunt generator, DC series generator, DC compound generator. Let us check out briefly about them. Now, let us see the self-excited DC generator. In self-excited DC generator, field winding is supplied from the armature of the generator itself. Here you may get a question that without generated EMF field cannot be excited, and without excitation there cannot be generated EMF. Then, how a self-excited DC generator works? The answer is residual magnetism by the field poles. Thus, when a generator started, the field poles possess some residual flux. This flux develops small EMF in the armature, which in turns armature drives a small currents through the field winding. This further increases the amount of induced EMF in armature. This process continues till the generator develops the rated voltage at the armature. The different types of self-excited DC generators are DC shunt generator, DC series generator, and DC compound generator.
We are one in IIE mission and vision, instilling excellence in electric